All right, thank you everybody today for joining us on today's webinar, Is Your Enterprise Building Ready for 5G? My name's Ben Stone, I'm with RCR Wireless News. Our speakers today will be Doug Bierbauer, Vice President of Marketing at Solid, and Kevin Vierling, CEO, Pando Telecom. Fiber to the edge for in-building mobile communications requires bringing fiber all the way to the antenna. With simple designs, easy installation, high bandwidth, and a high level of flexibility for tenant turnover and remodeling, Solid's fiber to antenna solutions are ready for the Middleprise. Just as a note, the webinar and the slides will be available for download after the presentation today. Please be sure to enter any questions that you have for our speakers during the presentation as well, and we will do our best to answer them at the end or follow up with you after the webinar via email. With that, I'm pleased to give it to you, Doug.
All right, thank you, Ben. Thanks for hosting, and Kevin, thanks for joining me on this. Everyone who's listening to it live, thanks for your time, and people who will watch it later, thank you as well. We're going to talk about getting your building ready for 5G, and some of that is, what's the process for doing it? Some of that is products. So we'll talk to both sides of that. Kevin, did you want to say anything to start off before I go into the next step?
No, Doug, thanks for having us. We're certainly honored to be here to talk about 5G and to talk about some of the solid offerings that enable and address some of these newer technologies that are coming to market. So we'll look for your slides to advance here, and then we'll certainly pipe up as we see necessary.
All right. Well, as people are still trickling in, I'm going to play a short video that talks about the 3 of the most common obstacles to having good cellular service inside the building. And after that, we'll get into the conversation.
How reliable is the mobile coverage in your building? Are your tenants, employees, and customers happy with their cellular service? How does this affect the value of your building? Several things may be causing the mobile service problems in your building. Solid provides cost-effective solutions to make it great. Mobile devices communicate with your service provider's network using radio waves. The network antennas are located on cell towers, rooftops, light poles, and similar locations. Natural obstacles such as hills and trees block these signals, creating areas with weak or no coverage at all. Neighboring structures also block signals. With modern, energy-efficient building materials, the greatest obstacle to good service is often your building itself. Low-E glass, metal, stone, brick, and insulation materials all reduce the amount of signal that enters your building. Interior walls, furniture, and equipment further degrade the signals as they travel deeper into your building. Weak signals are not the only cause of poor cellular performance, particularly in urban areas. It is possible to have so many competing signals arriving at a similar strength that they are noisy and not useful to your device. Perhaps the most confusing and frustrating condition is when there are good signals available, but the service is unreliable during busy times. 5 bars do not guarantee service. Cell sites serve many devices located outdoors, in vehicles, and inside buildings. Your building's occupants are sharing that site's limited capacity. Fortunately, there is a cost-effective, aesthetically pleasing solution to these problems. The EdgeRU installs simply, like Wi-Fi, and distributes cellular signals from multiple wireless service providers throughout your building. An EdgeRU Fiber 2 antenna DAS is engineered for your unique conditions to provide robust signals, overcome interference, and supply dedicated capacity. Your tenants need seamless, reliable, in-building coverage and the best possible experience provided with simplicity and value. Thank you for watching.
All right. Well, thanks for watching that, and it looks like we picked up a few more attendees during it. If you missed part of the video, there'll be a link to it in the slides that'll be presented to you. So with that, we'll get into 5G. What is it? Do I need it? How do I get it? we're not going to go into deep technical weeds here. We're not going to talk about 3GPP releases and things like that, but just on a basic level, what is 5G to you as a person responsible for providing connectivity in a building? And we're in the maximum hype zone for 5G right now. It's all over the television and commercials. Different service providers have different emphasis on it, but what does it mean to that person holding that mobile device? Well, there's three basic pillars to it. Enhanced mobile broadband. This is the one that I think is the most relatable. Okay, so it's better than 4G. Am I going to get faster download speeds, for example? And the answer is, well, that depends on the quality of the 5G, the type of the 5G. But in general, yes, over time, you're going to get very reliable, very high bandwidth connections to your mobile devices. The second pillar is that it will have lower latency. So this is going to enable a lot of the applications. And this one isn't so much about the coverage of the RF environment as much as it's the whole 5G network. It's a complete revamping of the network infrastructure before it's in radio waves. So as those networks get built out, hyper densified, we'll have much faster or less latency connections. So that enables things like gaming and like live replays at sports venues and things like that. The massive IoT is just that this 5G can handle many more connections than 4G or the previous generations could. So instead of tens of connections, it's thousands of connections. Kevin, you want to add anything on that? Clarify anything?
Sure, Doug. Largely since we focus on the end user and we focus on the enterprise environment, we do get this question very often. And some of it, there's a little bit of FOMO that exists there. Everybody wants to ensure that the infrastructure and the technology that they have in their facilities is the latest and greatest. But there's also some very great concerns out there and some great needs. When we look at the healthcare industry, for example, a lot of the users in those buildings are mobile users. And as a result, some of the daily functions that they perform on a regular basis involve sending a lot of data back and forth between devices that they use. So 5G in its various forms is becoming a hot topic for customers like that. And that's just one example. At the end of the day, largely what the enterprise is concerned about is, how can we enable all of these devices that we have with the best quality possible, not only from a throughput perspective, but also reducing latency as well. So this is a real thing. 5G is very real. The beauty of it, though, is it's not a change that happens overnight. It is an evolution. It is something that will take time.
Yeah, that's great. And so I think you actually touched on two of the points from the "Do I Need It" there, right? Is it, how can it optimize the actual workflow in a hospital or in a distribution warehouse, or just pick whatever industry you're in. And there are features of 5G that are going to, help your business flow better. The other one of the other ones is that expectations, right? Everyone is expecting 5G now. So again, you see it on television advertisements all the time. You look at your phone, it probably doesn't say 5G yet, or if it does, it's not quite the 5G you were looking for, but it will be over time. And so if you are in a position where you are leasing space in a building and your tenants are moving in and they don't have 5G, the point will come like, well, why don't I have that? Right? So it's an expectation.
The one question that we always ask our customers is, what is it that you want to do? What are your needs? What are your desires? And where do you see your business going? And that really, helps them better understand exactly, okay, there's all of these different technologies that are out there. Is 5G going to be the most applicable one to the things that we're looking to accomplish, not just today, but also in the future?
Yeah, absolutely. Building automation is the third point that I put there. Is that, there's a lot of things that we can do with various wireless appliances in a building for energy efficiency, for security. So it's not just about communication. There's many things that we can do with it. And 5G is more conducive to that than 4G, again, because it can handle so many connections. So how do we get it? Where do we start? A thing that's very important to me, although I'm in marketing now, I was an RF engineer for a lot of years before this role, is let's start by defining the problem. So I would say that how do I get it is first let's measure what the problem is. So if you are just perceiving that I don't really have good cell phone service in my building, let's go find out why. Maybe you lack signal. Maybe you got a lot of interfering signals, and that was touched on in the video. And so I think that's the absolute most important first step, and something that, Kevin, I think you can address more when we get to the next slide about the various services that companies like yours provide. And then once you have results of that measurement, now it's time to make a plan. What are the problems I'm trying to solve? What is it going to take to solve those problems? And then finally executing on it. And that is something that most enterprises are not going to self-perform. There's a lot of RF engineering expertise that goes into it. So finding a good partner to actually design and integrate these systems is very important. So with that, Kevin, what does a system integrator do for the enterprise?
Yeah, Doug, so as you mentioned, there is a lot of stuff that a customer can do on their own with their existing relationships, having relationships with OEMs, having relationships with cabling contractors. But still, when we're talking about 5G and we're talking about the cellular industry as a whole, there's still a lot of knowledge that needs to be addressed and needs to be relayed to all of these different key stakeholders. So, the role of the system integrator is really to, orchestrate and bring together all of these different stakeholders together so that you can deliver a solution that is addressing that first question, and that is, what are your needs, what are your goals? So, in addition to just the actual construction of the project or, the actual equipment side of things, there's a lot of other work that goes into these systems. Of course, there's always the benchmarking and the RF studies, right? What do existing signals look like coming into our facility? And more importantly, looking at the indoor environment, what do we need to do to overcome just the obstacles within the facility itself, right? Maybe we're dealing with a building that has lots of reinforced concrete, or maybe it's simply just drywall. Maybe it's a manufacturing facility or a warehousing facility, right? All of those different things have an effect on the performance and design of the system. So that's a key item for the system integrator to really address. There's things like the carrier coordination, right? So this is still a cellular technology, and it's largely at this moment in time still coming from licensed operators. I know we're going to talk about CBRS here moving forward, but we're talking about utilizing frequencies for 5G that are owned by companies that paid billions of dollars for them. So we need to ensure that they're in the know. We need to understand and make sure that the customer is aware of their processes and their procedures. And then after the system's been constructed and you've completed all the initial upfront items, there's the turn up, right? And it's not just as simple as turning on and flicking a switch and waiting for all the green lights to come on. There's certainly a lot of optimization that goes into it. First there's the discovery of all the devices in the system. There's, again, doing a benchmark study to make sure that all the devices are functioning properly and that your propagation models that you've worked with in the design phase are actually a reality in the field once it's turned on. And then finally, working with the wireless operators to do all of their system acceptance processes as well. Each carrier operates differently. They want to see different metrics and KPIs. And as a system integrator, we're aware of what those items are. So it's really key to ensure that each carrier is getting the things that they need so that they're satisfied and ultimately the end user is satisfied. And then just like any infrastructure or networking system, this is something that needs to be monitored and maintained. No doubt about it, stuff will inevitably not work when it first did. either as a result of the building evolving with different projects happening over time. Sometimes we do have equipment failures. Power supplies are very common with any type of infrastructure system that do fail. But someone needs to keep an eye on all this stuff to make sure that it's working. So the role of the system integrator is I think, goes undervalued at times. As much as we want things to be plug and play, we're very much in a world where the role of the system integrator is extremely important.
Yeah, that's great. Thanks, Kevin. And the alternative to a system integrator from the enterprise would be what? Either to try to manage all these things themselves, or perhaps going to a third-party neutral host type ownership model where they're doing a lease back, or what other options do they have?
Sure. I mean, they can certainly go out there and look for someone who might want to own and operate the system. There's various business models that exist out there, but with any decision to go in a different direction of not using a system integrator, you have to take into account the timeline of getting these systems deployed. Anytime that you're asking for someone to fund these particular projects, this is not a system that you're going to recognize and see operational overnight. This is really going to add a lot of time to the process because it requires a lot of people to come together and agree on the finances of a particular project. In addition, when you're looking at other models where the end user doesn't own it and operate it or work with a system integrator, they're largely subject to the people that own it to make updates to it and to manage and maintain it. And not saying that they don't do a good job. It's just that there is a third party involved there that's basically saying, well, this is our system, and we run it the way that we feel we need to. And sometimes the customer experience could be reduced in those circumstances. Either way, working with a system integration firm, there's a lot of us out there. Some do things better than others, and there's trade-offs there as well. So it really just comes down to, I think, is the customer wanting to own it? Do they want to have a hands-on experience with that and with their system integrator? Or do they want to have a hands-off approach where they just rely on someone else to manage and take care of the entire process for them?
Yeah, I think that's a very good explanation of it. Thanks, Kevin. Okay, so we'll move on now to some solution options. And obviously, Solid is in the left side of the screen with distributed antenna systems. But I want to start with signal boosters. I think that there's actually some good products out there in the signal booster category. But all three of these options, which I think covers most of the options here, is they all have their niche, right? So a signal booster is usually single carrier, although there are multi-carrier options out there, and they tend to be best suited to smaller venues with lower capacity demands. And part of this is just the amount of power that they're regulatory allowed to use, that limits the size of the capacity or size of the venue rather. But the capacity issue is really, I think, the key one, is that you're borrowing signal that is in the outdoor macro network and using it inside the building. And it's one of the things we touched on in the video, is that you can have signal and not actually be able to use it because it's already being used. Now, there are also hybrid systems between signal boosters and small cells where you can bring some dedicated capacity in and plug it into the infrastructure of the signal booster. So that's a little bit of a hybrid model. So that can give you a little bit more capacity. But small cells tend to be single carrier solutions. I think the holy grail for I don't know, is it decades now, has been the multi-carrier small cell. And because they're single carrier, in order to cover a medium or large venue for multiple service providers, it turns into an awful lot of small cells, which really drives up costs. However, the small cells are bringing capacity into the venue. You're not sharing it with the off-air signals, so it's got some advantages there. And it's not always necessarily an either-or proposition. You could have, you've got the hybrid of the signal booster with a small cell, or you could have small cells by themselves, or you could have a distributed antenna system in part of a venue and small cells in another, or even small cells as a low capacity signal source for a distributed antenna system. So then when we get to the left end of the chart here is distributed antenna systems. They tend to be, they don't have to be multi-carrier, but I think the economics of them lend themselves to being multi-carrier. It's a very large pipe that can handle many carriers and a lot of bandwidth. But again, the economics of it tends to skew it towards being deployed in medium and large venues. And then depending on how you segment the system, you can add as much capacity as the venue demands. So anything to add on that, Kevin?
Well, when I look at this and, we do talk about this quite a bit, all these different options. I think I'll go back to the slide previous, the value of the system integrator. And that is, we do touch on all of these different areas of solutions, right, for the end user. And there's a plethora of them. Make no doubt about it. There's a lot of options out there. And I think that, one of the things that good system integrators do is that they're able to educate their customer on all of these different options and help them understand the pros and cons of each of these. Not one of these solutions is right or wrong. It really just comes down to that first question that we keep asking, what is it that you're looking to accomplish? What are your goals? What are your needs and wants? Where do you see yourself in, 5 to 10 years? And depending on what that answer is, that largely helps you select the solution that's going to be right for you.
Yeah, I completely agree. Too often I see that the first question people ask is, well, what product am I going to use? And they haven't defined the problem. They haven't measured their environment. They don't know how much capacity they need. And I think they do a disservice to themselves. And I think certain consultants do a disservice to the enterprise. You see it in Division 27 specs all the time, where they basically hard-coded a product choice without defining what the problem is. And it just doesn't benefit anybody. Okay. So we're going to talk now a little bit about the EdgeRU, which is a fiber to the edge distributed antenna system. Why is it fiber to the edge? For years we've been doing coaxial based distributed antenna systems. In more recent years, we've had some fiber to the edge DAS and some category cabling to the edge DAS, and now Solid has a newer fiber to the edge distributed antenna system model. Why is the market shifting from the coaxial based distributed antenna systems to more active to the edge distributed antenna systems?
Well, what we're seeing is, just with the nature of the new technologies that people are concerned about, not just 5G, but, Wi-Fi 6 and some of the other roadmap for all these different technologies in the future, they're bandwidth intensive. And, putting fiber out to the edge where your active devices need to be, it's a very forward-thinking approach right now, but I think in the future, we're going to start to see this be a more standard practice simply because we do have all these data intensive, data hungry devices and services that, require that type of bandwidth that fiber can offer.
Yeah. I heard that my audio is fading in and out. I apologize for that. I'm not sure why. So hopefully you can hear me well enough. Okay. The choice of fiber or category cabling to the edge, what's the pros and cons between those two?
I'm sorry, repeat that question?
Could you speak to the pros and cons of category cabling and fiber to the edge?
Sure. Talking about fiber, the topic at hand, fiber offers a lot of bandwidth capability. So, not only can we can use multiple wavelengths to be able to, segregate different technologies, different services, and essentially, at this moment in time, it's limitless, right? As far as the capacity and the capability that we can push through over light. I would say, one of the challenges that we do have with fiber, in contrast to copper, twisted pair cabling, is fiber doesn't have a power capability. One of the nice things that still exists in the twisted pair world is that in addition to getting that signaling and that bandwidth, you're also getting power for your devices out there in the ceiling. Now, I know you guys have addressed that. You guys have a great solution here that integrates not only the fiber, but also provides power. But what we're looking at is not just pulling fiber out to the ceiling. We're looking at pulling copper as well to drive power, electrical power to these devices that need it. So it's not a problem, but it is, since we have been in a world where we're used to pulling a single cable out that provides both services. In the fiber world, we have to look at not just pulling fiber, but also pulling copper. And in doing so, there are great ways to solve that problem. With a composite cable, a lot of manufacturers offer not just a cable that has fiber, strands of fiber in it, but also it has strands of copper in there as well. So again, I look at this technology and this solution, this infrastructure play to be a very forward-thinking idea. If we just look at the writing on the wall, there's all of these devices that require a lot of bandwidth, and the best way to address that in the ceiling is going to be with fiber. You certainly can't go wrong with putting fiber out there, only simply because a device right now might only have a gigabit requirement. In the future, there might be a device that has a 10 gigabit requirement. And then maybe 5 years from now, we have devices that have a 40 gig requirement. We don't know, but we do know that the fiber is in fact going to be handling that. And there's going to be no need for a rip and replace scenario.
Yeah, absolutely. Yeah, I think that's really the key is, it's not really just about distributed antenna systems. If we're going to put infrastructure in the ceiling, we want it to be able to support that appliance and whatever other appliances that the enterprise needs, whether that's 4K cameras or environmental controls or whatever it is. Now you've got the fiber out there, you've got the bandwidth. If you pulled the copper conductors with it, you've got the power for the other appliances as well. And just to touch very briefly on millimeter wave, millimeter wave probably won't be deployed in building for 5G right away, but it will eventually. And that's going to require, massive bandwidth, as you were mentioning. There are things coming that are going to require 10, 20, 40 gig connections. So having the right infrastructure should pay dividends over time. So the topology of the Alliance EdgeRU is very simple. It uses the same head end as the rest of all of Solid's Alliance distributed antenna system products. And it has the Edge Hub, which is like a floor level or IDF level, one rack unit piece of equipment that relays the optical signals out to the EdgeRU remotes and also provides the DC power. It's low voltage NEC class 2 type power. So in most jurisdictions, it doesn't require an electrician or a conduit. Of course, check your local codes. So that supports 8 optical connections out to EdgeRUs. But in order to scale the system, it can expand to up to 32 off of that one box. And I'll explain that in subsequent slides. So this is a picture of the EdgeRU. It's less than 9 inches square and it only shows about 1.5 inches below the ceiling. So it's pretty nice. It's pretty small. And it has really good output power into the antennas, about 23 dBm per band for the high bands. And the antenna has really good pattern, which maybe some other products can have a high gain number on the data sheet, but directs a little bit too much of that energy straight down. This is a very nice towards the horizon pattern, and we've been collecting data in our headquarters lab where we have this system installed, and it's matching predictions very well. We'll be putting a white paper out about that soon. We're just waiting for some reports to be finished. The EdgeRU is also available with internal antennas and with external antenna ports. So the external antenna ports could be used because you want to use, say, a panel antenna. It can also be used because you're deploying it in a large sports arena and you want to use those stadium style antennas that have like per band connections rather than one connection for multiple bands. And we created the first model of the EdgeRU to support bands for all of the service providers. So it's got the 700 band, the PCS band, the AWS band, and the 2500 band. And then we created an add-on remote to it to fill in the remaining bands. So you can get all the current cellular bands. We can add the 600, the 800, 850 band, the 2300 band, and CBRS. And something to point out for both of those is that the 2500 band is full band coverage. It's 194 megahertz of the 2.5 band. And for CBRS, it's the full 150 megahertz. So we think that that's valuable because if you're the enterprise and you want to do some use CBRS for, say, a private network in your building, you don't want to be limited to just 20 megahertz or 40 megahertz of that. You put in the infrastructure, you've gone to all the effort to get it installed, support the whole band. That gives you the opportunity to use it for your own needs. Also gives you the opportunity to monetize that for other carrier connections that want to use CBRS, or maybe you don't monetize it and you just let them use it and they bring more capacity into your venue. So it gives you more options. The EdgeRU expansion there from one remote with 4 bands to a second remote with the additional 4 bands is done without pulling additional fiber. So you only pull fiber to the first remote, and then you install the add-on remote a few feet away, and then there's just some short jumpers that connect over to it. The power from the Edge Hub, each one of those DC pairs provides enough power for both the main and the add-on remote. And there's another way that you can expand the system. This is with optical cascading. Basically, it's just using an optical coupler, so you can feed 2 of the main EdgeRU remotes. So now instead of there being 8 remote connections optically, you can get 16 off of one Edge Hub. And you can do both things together. You can do the optical cascading to 2 main EdgeRU off of each optical port, and then you can still add the add-on remotes. This is a tremendous amount of cellular bandwidth. It's 595 megahertz if you add up the full bandwidth of all 8 of those bands. If you go to this with up to 32 remotes off of one Edge Hub, we do need one supplemental 1 rack unit power supply for the 17 through 32nd remote. And that's what it looks like installed. If you were to put 2 of them on one standard 2 foot by 4 foot ceiling panel, you see that it's low profile, and it's so easy to install that even a marketing guy can do it. So I actually installed this system in our headquarters, so I would understand how it's done. And that is the end of the pitch for the EdgeRU. I'm hoping that there's some questions that can come in, and we can answer any questions that everyone has. Kevin, did you have any comments about the EdgeRU? You haven't had an opportunity to work with the product yet, have you?
Not just yet, no. We have seen it, and one of the things that you pointed out in one of your slides that's really important to us, from an integration standpoint, but also to educate our users, is that it's a very aesthetically pleasing device. Without someone knowing that this is a cellular remote, if you will, it looks and deploys just like Wi-Fi to some degree, and that's really important for people who live in a Wi-Fi world, right? When we talk about the indoor space, we're so used to, at least IT professionals are very used to seeing a device in the ceiling that's broadcasting radio frequencies. And when we have a device that looks similar to those type of legacy solutions and deployments, this really resonates with them when they see this. So it's something they can certainly get behind a lot quicker than some of the traditional topologies of DAS that we've seen in the past.
Yeah, I think it really is so simple to install that an enterprise could make the choice to do the installation themselves if they have in-house low voltage installers. That doesn't take away from the system integrator's role and all the engineering and coordination that goes into the solution. But I think more often than not, they'll probably have the system integrator do the installation.
So Doug, there are quite a few questions here, and I don't know if you're able to see them, but there is some stuff here
Yeah.
that people are really curious about.
Sure, we could run down through a bunch of these pretty quick. Do you want to take one first, and then I'll take one?
Sure. I mean, a lot of these are going to be specific to the product, so I'll do my best based on my knowledge of it. Does a single unit support all technologies, or does it need an additional unit to cover 5G and for other legacy technologies? So I think from the one slide and based on what I know of the product, each unit consists of approximately 4 radio frequency bands. And as we know, the wireless operators, some operate in 2 bands, some operate in 4, some operate in 6. So, this really comes down to, at least from our standpoint, knowledge of the networks and knowledge of, as a system integrator, understanding what the carrier truly wants to see. What we see in the indoor space is that sometimes 2 bands is enough from a wireless operator. Sometimes they want all of their services available, all right? In which case, looking at this product, the way it's designed and configured now, and you can purchase it, it is 4 bands at the moment. And then as Doug has pointed out here in these slides, you can either run a second unit or cascade a second unit to increase the number of frequency bands that you can offer at any given location. And, with respect to it covering 5G, when we're talking about 5G, obviously there's a lot of interpretations of this particular term. So in many cases, if we're offering a number of the existing frequency bands sub 6 gigahertz today, a lot of the carriers are taking advantage of some 5G features. So then yes, the answer is it is 5G. When we're talking about some of the newer frequencies that are going to be used for the 5G networks up in the millimeter wave, Doug, I'll let you speak to how that would be addressed from this with this solution.
Yeah, so as I mentioned earlier, I think that 5G millimeter wave in building has a little bit of time before there'll be a large demand for it, but that it is inevitable. And so we're developing developing millimeter wave solutions now that are off-air based, called Rocket Wave. You'll see a lot more about that from us soon. But there is sort of a convergence path between that type of solution and our EdgeRU that can happen in the future. We'll tell you more when we get closer to that, but absolutely. And that's the importance of pulling that fiber out here, is that when you want a millimeter wave solution, it can look very similar to this as an architecture, but it is very, very large bandwidth. This is 8 bands that comprises about 595 megahertz. A single band of millimeter wave might have 800 megahertz of instantaneous bandwidth. So and then that could be for one service provider. You have multiple service providers, and it's a huge amount of bandwidth.
And Doug, I think it's important for our listeners to understand that, with 2 EdgeRU devices, you're basically addressing all of the existing sub 6 gigahertz bands that exist today for each of the wireless operators.
Absolutely, yeah. And we have other models that are in development that'll be released in 2021. This first pair that we created, we solicited feedback from carriers and from third-party owners and from enterprise customers, and that's why we decided to do one that was sort of a compromise, where there was a band or 2 for each of the service providers. We've also received feedback from some of the service providers, hey, how about one that covers our 4 main bands? So we're working on that as well. And then also, how about a remote that's just dedicated to CBRS? And what about the mid-band, the other spectrum, say they're from 3800 to 3980, so, or 3700 to 3980. So we have plans for those as well. So we could have a remote that has CBRS MIMO and C-band MIMO, all in one remote. So if you wanted to have a very robust private networking solution, then this product line will support that as well.
So Doug, some easy questions I think here to address as well. You mentioned MIMO and CISO. Out of the box, how do we address that configuration with these devices?
Sure. So the models that I have on the screen right now are CISO. So if you wanted to have 2x2 MIMO with it, it'd be 2 layers. But if there was, say someone wanted 2 bands of MIMO, right? That is something that the architecture can support. We just haven't had the demand for that yet, right? So if one of the big 3POs or one of the 3 big major network operators come to us and say, hey, we want 2 bands of MIMO on these 2 bands, we're all ears. So just let us know.
Another question here, which type of fiber and interface connector does this product utilize?
Okay. So the connections from the Edge Hub to the EdgeRUs are LC APC. The connection from the head end, from the IBIU to the Edge Hub, is SC APC. So if you can see the slide that I'm displaying right now, if you look at the very top right, there's a connector that's a different form factor than the other. So that's the connection to the head end, and then the 8 or the 4 pairs of the other optical connectors are LC APC to go to the remotes.
Great.
And it's all single mode. Sorry, in case they were wondering that as well.
ROU, correct me if I'm wrong, remote optic unit is the
correct. Yep,
acronym.
That's right. Yes.
Let's talk about the power. There's a question here with respect to the power. So, we do have limitations as far as, how much voltage and how much wattage we can put out to these devices. Is the EdgeRU Class 2 limited?
Yes, it is. So each one of the DC blocks at the Edge Hub is limited to 100 volt amps. And the power consumption of each EdgeRU is very small, so that even 2 of them falls well below that limit.
Okay. Unfortunately, Doug, I have to have you repeat that. You definitely cut out a few times there.
Okay, sorry. Can you hear me now?
You are good.
All right. The Edge Hub, each one of the DC power blocks is limited to 100 volt amps. And the EdgeRU's power consumption is very small, so that even 2 EdgeRU connected to one of those DC power blocks would be well under the NEC Class 2 limit.
Great. So there's a question here, what sort of coverage area for a typical commercial space are you seeing for the EdgeRU and the 2.5 gigahertz band, and with the full 100 megahertz channel bandwidth? And I assume that's it's with 2.5. So, Doug, I don't know if you guys have case studies at this point or firsthand experience on what you're seeing with that particular frequency, but largely I would say, this is kind of one of those answers where it really depends, right? I mean,
it sure does.
It depends on the environment that you're in. It depends on how many channels you are in fact passing through. In this case, it looks like the question came for 100 megahertz. It really just all varies on certain things. So I'm not really willing to comment on exactly what type of square footage coverage this provides. I would say it largely just comes down to what the requirement is from the carrier. Is it a neg 95 requirement? Is neg 100 sufficient? What does the existing signal to noise ratio look like? There's all these factors that come in. And
yeah, and it's the most reasonable question for people to ask. And it's always the first question that comes up. And then all of us, people who've worked with RF go, well, it depends. So we give them the diaper answer, and it's not satisfying for anyone. But it's just the truth is that, how much interference are you overcoming will determine, what your signal level is. They did answer, how much bandwidth we're talking about. So I can tell you that in an fairly open office environment with sheetrock walls and 100 megahertz, in the 2500 band is usually going to be the limiting band from a power perspective. That we're seeing about 10,000 square feet in our headquarters, which is fairly open office environment. We do have sheetrock enclosed offices, and it's covering very well. And part of the reason for that is that antenna design that I mentioned earlier. Is that our R&D did a really great job with our antennas. And I believe we have 5 dBi directivity for that band, and the higher bands have higher gain than the lower bands, which is appropriate. And so we're getting very, very good coverage from the units. We're going to put that information out there for everyone to see soon, because I know for a lot of people who have experience with some other active DAS products, that's been an issue, is that the antennas that were integrated in the units just didn't live up to expectations or didn't match the VEX files that were used in the design tools. So stay tuned for that, and then you can judge.
Going back to the power topic, what are you guys seeing on average as far as distance limitations? And I know that this is variable of the size copper that you use in the composite cable. Do you guys have any rules of thumb that you educate integrators to work with?
Yeah, I believe that we've published that inside of our data sheets or in the installation manual, and I apologize, I can't remember which it is off the top of my head, but all of that documentation is available through our website. All the data sheets are open for download to anyone who'd like to see them. And if you want the installation manual, you can just contact us and we'll shoot it right over to you. Or if you already have a sales rep with us, then they'll be more than happy to oblige. But we've got a table in there that explains those trade-offs between the wire gauge and the distance. I can tell you that in our office, I just used 18 gauge wire, and I think the furthest remote was 250 feet from the edge hub, and the voltage drop was negligible. So there was plenty of room to go further.
Great. I think that's a great calculation that's easy to, having that in your documentation makes it really easy for people who are designing these systems. Some of the things I've struggled with as a system integration firm is, when obviously you're deploying custom solutions, there is a lot of engineering involved, and that's what people are paying you for. But sometimes there's some things that you just do so much that you just wish that you had it somewhere set aside, kind of as a cheat sheet, if you will. And I think that having that particular one, especially since, pulling fiber with a composite cable out to the ceiling is going to be new to some folks, having that information offhand is really going to be helpful for them as they look at considering the solution.
Absolutely. I see a couple easy questions to answer here. One from Bill asking about the composite cables consisting of copper and fiber. I think at some point we might have created some confusion that it was fiber only, but yeah, you answered it, Kevin, that it is a requirement to have some DC copper conductors pulled alongside the fiber. That can be under one sheath in a composite cable. It can also be pulled in parallel, right? And that's how I did our office, is that we pulled the copper conductors alongside of the fiber, pulled them together. So it wasn't separate poles, but they were coming off separate reels. Okay.
And there's one final question here that we didn't actually address yet, and it's from Mr. Luke Lucas. Luke, thanks for joining. Your question is, how real time is your carrier standards applied to projects? I don't know if that's a question for Doug or myself, but I can certainly speak to it. And as I'm speaking, if you want to clarify a little further, we'll certainly look for that question. We'll address it accordingly. But as a system integration firm, one who's educating the end user on what they need to do to ensure that they're meeting the requirements of the wireless operators, not just from a standard standpoint, but also from a KPI and metric standpoint. That is something that we kind of, that's the education process. That's what we're explaining to the end user to say, hey, XYZ wireless operator operates in these 4 bands. We're starting to see that they have a 5th band that they would like to see deployed indoors. And, if you don't have that band readily available or have a path for them to be able to recognize that, you're going to find yourself very challenged, the end user being challenged in getting that wireless operator to agree to connect to your system. So that's one of the education points that we take upon ourselves as the integration firm to make sure that the end user is aware of, just so they know that, there is this standard, there is this requirement from the wireless operator. And, depending on whether or not you choose to abide by those particular rules, that'll have a large impact on, how cooperative the wireless operator will be to connect to your system.
Yeah, and I would only add that, the emphasis even of this webinar is the importance of the system integrator. They're the ones who are talking to the carriers and coordinating on behalf of the enterprise to make sure that the carriers' requirements are going to be met. And, that's important not just from a relationship, but, for satisfying the carriers, but it's the reputation of our equipment. So we are selective in who we consider a partner. If they are not doing their job, then we won't work with them. So very important that the carrier's interests are represented. And I think system integrators are the best way to make sure that happens. Okay, Ron asked about the maximum wire size. It's 14 gauge, Ron. All right, and Luke sent us an update. Thank you, Luke. Super. Any other questions? I think we're at the end.
Okay, great. Well, thank you everyone so much for your time. Thank you, Doug. Thank you, Kevin. This concludes the webinar.
Okay, well, I was going to play one parting video as people leave, and again, the link will be in the slides if you wanted to watch it later. And if it's all right, then I'll launch that, and people have a nice day.
Thanks, Doug.
Solid Alliance 5G distributed antenna system. Introducing the new EdgeRU Fiber 2 antenna remote. Featuring an attractive low-profile ceiling installation with an integrated antenna that installs as easily as Wi-Fi. Each EdgeRU provides 4 frequency bands with add-on capability to support a second EdgeRU with 4 additional frequency bands, including CBRS for private networks. Your customers and employees need reliable cellular coverage. You need a cost-effective solution that is easy to install, simple to manage, and able to adapt to future demands. Solid Alliance 5G DAS requires a small footprint in the main telco room for the IBIU head-end equipment. From this central location, fiber optic cables distribute the multi-carrier signals to telco closets on each floor. A single strand of fiber connects to an edge hub in a telco room on each floor. From the edge hub, single fibers connect to up to 8 main EdgeRUs that provide 4 cellular frequency bands. The edge hub also provides DC power over copper conductors to the EdgeRUs. These conductors may be pulled parallel with the fiber cable, or a composite fiber and copper cable may be used. The EdgeRU features a low-profile ceiling mount option using integrated antennas. The EdgeRU also features a wall mount option using external antennas. That is the entire system ready to provide your customers and employees with cellular coverage from multiple service providers. But what will you do when new technologies and frequency bands emerge in the months and years ahead? Solid Alliance 5G DAS is prepared to solve tomorrow's problems. Without pulling additional cables, you can upgrade this system to support 4 additional frequency bands, including CBRS to support private networks. At the head end, install a second IBIU below the main IBIU with input cards to support the additional frequency bands and signal sources provided by the wireless service providers. The secondary IBIU signals are combined into the main IBIU and sent over the previously installed fiber. Each of the EdgeRUs connected to the Edge Hub supports 1 add-on EdgeRU. You simply install the add-on EdgeRU nearby and connect short jumpers to provide signal and power. That's it. Edge connectivity for today, expandability for tomorrow.